Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths E. We have started a discussion with the 2A from the basic chapters of complex numbers, De Moivre's theorem, and we learned quadratic equations, right? Today we are going to start a new basic chapter, which is a basic things for most of the geometrical and all other algebraic chapters also, that is partial fractions. What do you mean by this term? The fraction itself, we know that it is always in the form of p by q. Then what is this partial fractions? Why do we need to partialize this fraction? Is it right? Just tell me, when do we say it, we are doing it partially? That is, we have to do it in the parts. A simple fraction cannot be written in all the times. Okay, so we have to segregate into number of parts. Yes, for example, if you tell, can I write 1 by 2 as 1 by 4 plus 1 by 4? Why? Because I can't use half all the time in a few cases. So, it is very important to write a single expression into number of partial expressions. Okay, fine. So, what is that we are going to learn in this partial fractions is, we are going to segregate a single fraction into multiple fractions, maybe 1 or 2 or 3 based on the denominator. Okay. Before going into the actual content, first we know that partial fractions are of two types, proper and improper, right. When do we say it as a proper fraction? When a simple thing is, if it is in the non-polynomial thing, if it is a real thing. So, we will tell as numerator is less than denominator. If numerator is less than denominator, then it is called as proper fraction. If it is improper, numerator is greater than or equal to denominator, then it is called as improper fraction. Similarly, when it comes to expressions or polynomials or equations, this kind of algebraic things, fractions can be segregated as proper and improper in such a way that the degree of numerator is less than degree of denominator, then it can be called as proper fraction. You have to remember this. Throughout the chapter we will first check whether it is proper or not. Okay. Similarly, improper is degree of numerator is greater than or equal to degree of denominator. Is it right? Fine. Once we know that it is a proper fraction, then we will start doing partial fractions. First, we will have 4 types of finding out. First, let us discuss with the first 2 types. Then after doing that, let us discuss the next things. Type 1 is, the first condition is the fraction should be proper. That is, let us assume f of x and g of x as proper fraction. Then the first thing, everything depends upon the denominator. Then for the type 1, the denominator g of x should be in the form of x minus a into x minus second factor and so on. That is, no factor should be repeatable and they should be reducible. That is, all factors are, or else instead of writing as factors, let me write it as poles. Okay, remember the term. Poles is finding the denominator. Okay, or else let me write all factors of g of x are reducible and non-repeating. Okay. What do you mean by the term reducible? Let us say x minus alpha 1 is one as a factor. If I equate it to 0, I will get it as alpha 1 as 0. Yes? Yes or no? What if it is in the form of x square plus alpha? Can I get a real value? No, right? Why? X square can never be equal to minus alpha 1. Right? So, all the factors of the denominator should be reducible and it should not be repeating. So, I can write the fraction as a by first factor, b by second factor plus c by third factor and so on. We can have multiple factors like that. Is it clear? Did you understand? What if the factors of the denominator are repeating? Tell me. Let us say that it will be a type 2, remember. Let us say g of x is in the form of x minus alpha 1 whole square, x minus alpha 2 whole square and so on. Okay. Then we will write the fraction as a by first factor plus b by square of first factor, right. If it is repeating 3 times, we will write c by that term, okay, plus again this is separately d by x minus alpha 2 whole square and so on, whatever they are. Okay. What are these? The denominator factors are reducible but repeating. Yes, is it okay? Type 1 and type 2. Did you understand? Shall we start doing the problems of at least these 2 types? Let's do. Look at the first question here. They gave resolve 3x plus 7 by x square minus 3x plus 2 into partial fractions. First, what is that we have to see? Just check whether a given fraction is proper or not. How can we say a given fraction is proper? When the degree of the numerator is always less than the degree of denominator. Just check and tell, what is the degree of numerator? 1. Yes, there is no other term other than x. Here what is the degree? X square, the highest power is 2. So, I can write it as here the degree of numerator is less than degree of denominator. So, I can write it as given fraction is proper. Yes. Now, that is done. Next, second step, check whether the denominator has reducible or irreducible roots. So, let us factorize it first. X square minus 3x plus 2 can be written as factors of 2, 2 ones are 2, minus 2x minus x plus 2. That is, if I take x as common, I will get it as x minus 2. If I take 1 common, I will get it as x minus 2. If I take x minus 2 common, I will be left with x minus 1. So, these are reducible and non-repeating. So, the fraction becomes as, let us write it as f of x by g of x is equal to 3x plus 7 divided by x minus 2 into x minus 1. Is it right? So, which type we can use? Type 1, right. So, the first step, let 3x plus 7 by x minus 2 into x minus 1 can be written as a by first factor plus b by second factor. Isn't it? A by first factor, b by second factor. So, let us cross multiply. What do we get? 3x plus 7 by x minus 2 into x minus 1, that is equal to, let us take LCM here, we will be left with x minus 2 into x minus 1, cross multiply, a into x minus 1, b into x minus 2. What is the main thing we have to do here is, after cross multiplication and simplification, we have to find the values of a and b and substitute it here. Okay, that is the only main theme. Just both the denominators are same, we will cancel it. So, 3x plus 7 is equal to a into x minus 1 plus b into x minus 2. Fine. We can do it in multiple ways. So, let me show the simplest method, that is substitution method. If I substitute x equal to 1, this term will be lost. If I substitute x equal to 2, we can remove this term, right. So, let us do that. Put x equal to 1, let us take it as 2 in 2. What do we get? 3 into 1 plus 7 is equal to a into 1 minus 1 plus b into 1 minus 2, that is 3 plus 7 is equal to 0 plus b into minus 1. Therefore, minus b is 10, therefore, the value of b is minus 10, isn't it? Now, let us substitute x equal to 2 here. What do we get? 3 into 2 plus 7 is equal to a into 2 minus 1 plus b into 2 minus 2. This both will get cancelled. I will be left with 6 plus 7 is equal to a into 1 plus 0. A is equal to 13. Now, substitute the values of a and b in this first one. Substitute a and b in 1. Therefore, the partial fractions I can write it as 3x plus 7 by, let me write this, x square minus 3x plus 2 is equal to a by this term. What is a? 13. 13 by x minus 2. What is b? 10 by x minus 1. Is it not easy? What is the main thing we have to remember? First, we have to check whether it is proper or improper. Then, check whether the denominator is repeating, non-repeating, reducible, irreducible. Okay, 4 different kinds. Okay, for if it is reducible, we will have repeating, non-repeating. If it is irreducible, we will have again repeating, non-repeating. 4 kinds. We are doing only first 2 types. Clear? Is it okay till here? Shall we move to the next problem? Let's do. Look at the next question here. He is asking us to resolve this particular expression into partial fractions. First step, what is it? Check whether the degree of numerator and the degree of the denominator are same or more or less or whatever. Here, what is the degree of numerator? 2. Degree of denominator? 3, the highest degree, highest power. So, I can write degree of numerator is less than degree of denominator, right. So, it is a proper fraction, therefore, it is a proper fraction. And can I write x cube plus x square as, can I take x square common? I will be left with x plus 1. Okay. How many factors are there? X, x, x plus 1. 3 factors. X is repeating 2 times. So, I can write it as, here denominator is reducible and repeating. So, we can tell it as type 2 equation. So, let us assume now, let 2x square plus 2x plus 1 by x cube plus x square is equal to a by x, and the next b by x square plus c by x plus 1, right. Since the denominator is repeating, we will write it as second term. Done. Now, let us take LCM here. Let me write the same thing here, x square into x plus 1, that is equal to x square into x plus 1 is LCM. Now, here a into only x is there, I will be left with x, x plus 1, and here x plus 1, and here x square, right. Let us cancel these both. Next, equate it. 2x square plus 2x plus 1 is equal to a into x square plus x plus b into x plus 1 plus c x square. Let us simplify this. What do we get? 2x square plus 2x plus 1 is equal to ax square plus ax plus bx plus b plus cx square. Once again, ax square plus ax plus bx plus b plus cx square. Now let us take x square common here. Then let me write this again. Why I am writing is all the time since it is, I mean, even though it is same, because we have to compare the coefficients now. Let us take x square common. I will be left with a plus c, right. If I take x common, I will get it as a plus b, right. Is it okay? So, let me equate all the coefficients now. What do I get? X square ka coefficient a plus c is equal to 2, x ka coefficient a plus b is equal to 2, constant b is directly 1. Okay. In the last question, how did we do? We used to substitute only x equal to 1, x equal to like that. Here also we can substitute, but we'll get, it will be a kind of hectic. So, we got b is equal to 1 here. Let me substitute that here. I will get it as a plus 1 is equal to 2, a is equal to 2 minus 1, a is equal to 1. Okay. Let us substitute the same here. I will get 1 plus c is equal to 2, c is equal to 2 minus 1, c is equal to 1. Then let us substitute a, b, c value in the equation 1. Substitute a, b, c in 1. So, what are the partial fractions? 2x square plus 2x plus 1 by x cube plus x square is equal to, what is a? 1 by x. What is b? 1 by x square. What is c? 1 by x plus 1. Right? Are we able to write a single fraction into multiple fractions? Yes. Is it not easy to solve? The only thing you have to remember is we have to assume. How do we assume and everything? Fine. Till here, is it okay? Shall we go to the next problem? Let's do. Look at the next question here. He is telling resolve this particular expression into partial fractions. Right? And again check here, both are reducible and this is repeating. From now I will write it directly. Fine. What is the degree here? X ka degree is 1, x ka degree is 2. Therefore, here x ka degree is 2 in the numerator. So, it is a proper fraction. So, it is a proper fraction. Second, the denominator is reducible and repeating. Is it fine? So, we can write it as, let x square minus x plus 1 by x plus 1 into x minus 1 whole square is equal to a by x plus 1, b by x minus 1 plus c by x minus 1 whole square. Okay, once again, a by first term, b by x minus 1 and c by x minus 1 whole square. Clear? Is it okay? So, let us simplify now. What do we get? That will be LCM is x plus 1 into x minus 1 whole square. Therefore, this will be a into x minus 1 whole square, b into x plus 1 x minus 1 plus c into x plus 1. Isn't it? A into will get whole x minus 1 whole square term, b into this one term and this one term, c into x plus 1. Is it right? And left side, x square minus x plus 1 by x plus 1 into x minus 1 whole square. We will cancel these both terms. Yes. So, again let us simplify the numerator. So, what do we get? X square minus x plus 1 is equal to a into x square plus 1 minus 2x plus b into x square minus 1 plus c into x plus 1. Let us simplify this. What do we get? Ax square plus a minus 2ax plus bx square minus b plus cx plus c. Is it clear? Now, let us take x square as common, a plus b into x square, and x ka common, if I take minus x as common, I will be left with 2a minus c plus a plus c. Here it is a square minus x plus 1. Clear? Check again. Ax square bx square minus 2ax minus c, okay, and the next a minus b plus c. Done? All covered, right? So, let us equate all the coefficients now. What is left? A plus b is 1, 2a minus c is again 1, and next a minus b plus c is also 1. Clear? Is it okay? So, let us add, let me take it as 2, 3, 4, because however this is 1, right? Solve those 3 equations, however you want to solve you can, okay. As of now, let me add second and fourth equation. Why? Because b will get cancelled. A plus b equal to 1, a minus b plus c equal to 1, b will get cancelled, I will be left with 2a plus c equal to 2, right. Let me take it as equation 5. Now, add 4 and 5 and 3, 5 plus 3, what will be left? 2a minus c equal to 1, 2a plus c equal to 2, c will get cancelled, 2 plus 2, 4a, 1 plus 2, 3. What is the value of a now? 3 by 4, right. After getting the value of a, can we substitute it here? From 2, 3 by 4 plus b is equal to 1, b is equal to 1 minus 3 by 4, that is 4 minus 3, 1 by 4. Similarly, from 3, 2a minus c is equal to 1, 2 1s are 2 2s are, I will be left with 3 by 2 minus 1 is equal to c, c is equal to 1 by 2, fine. Now, let us substitute a, b, c in the first equation. Therefore, the partial fractions are 3 by 4 into x plus 1, 1 by 4 into x minus 1, and the next 1 by 2 into x minus 1 whole square. Are these questions easy to solve? Yes? Yes or no? We have seen all different varieties of solving in the initial problems itself. Clear? Is this okay? Fine. This is for today. Let us meet in the next session with more problems of partial fractions. Thank you.